Next up, we're going to prove a rhombus using coordinate geometry. Again, there's multiple ways you can go about this. Since it's in the parallelogram family, some of that is to first prove parallelogram, then show some other property that only a rhombus has. But we're going to stick, again, with the definition. So we want to show that all four sides are congruent. How do we show a side is congruent? This is where we're going to now use the distance formula. Distance formula shows congruent sides and a congruent length. Right? Slope just shows you if they're parallel or if they're perpendicular. Distance formula shows you sides are congruent. So let's do this. And of course, what we're showing is they all have the same distance. So let's first graph it 1, 5. That's M. Negative 1, 2. There's our A. 1, negative 1. There's our T. And H, 3, 2. There's our H. So there's our rhombus. We want to show that all the sides are congruent. So we're going to do distance formula. So let's do the distance of MH. Remember, review, if I don't write the segment bar over the top, it means the measure of MH. I could write it like this. Little m means measure of segment MH, or I could lose the little m and the segment bar, and this means the length of MH. So that's going to be the square root of x minus x with m and h. So let me write down those points. M is 1, 5. H is 3, 2. So we've got x minus x, 1 minus 3 squared, plus y minus y, 5 minus 2 squared. That is going to be equal to the square root of negative 2 squared plus 3 squared, which is equal to the square root of 4 plus 9, which is equal to the square root of 13. So that is the length of that side. It's the square root of 13. Now let's do the length. I'll write it in there, square root of 13. Let's do the length of MA. So M, again, is 1, 5, and A is negative 1, 2. Whoops. Buy myself a little bit of room. Square root of x minus x, 1 minus negative 1 squared plus y minus y, 5 minus 2 squared equals the square root of 1 minus negative 1 is 1 plus 1. So that's going to be 2 squared plus 3 squared. That's going to work out to be the square root of 4 plus 9, which is the square root of 13. So MA is the square root of 13. Now we're going to do AT. So A is negative 1, 2, and T is 1, negative 1. So we've got our square root of x minus x squared plus y minus y squared. That's going to be the square root of negative 2 squared plus 2 plus 1, because the minus and negative is a plus, 3 squared. So that's going to be the square root of 4 plus 9, which is equal to the square root of 13. So that distance from A to T is the square root of 13. Lastly, we're going to do TH. So T is 1, negative 1, and H is 3, 2. So TH is the square root of x minus x, 1 minus 3 squared plus negative 1 minus 2 squared. That's the y minus the y. So we've got the square root of 1 minus 3 is negative 2 squared. 1 minus 2 is negative 3 squared. So we've got the square root of 4 plus 9 equals the square root of 13. So you can see that it's a rhombus. It fits the definition. All four sides are congruent. Of course, you have to write something about that. So we have to say since all four sides have the same length, the quadrilateral is a rhombus. Again, I can't stress enough that when you do the take-home test, you've got to be making these concluding statements. You can't just show me some numbers and go, done, they're all square root of 13. You have to make these statements. So that is how you show a rhombus.